In this lesson, we will cover the chain rule. The chain rule is a method for finding the derivative of a function within a function. So, d dx f g of x equals f prime g of x times g prime of x. So what this means is when we have the function g within the function f, we first find the derivative of the function f, keeping g of x the same, and then we multiply that times the derivative of g of x. The power rule is often combined with the chain rule. So that would look like d dx u to the n equals, then we take the exponent, put it in front, and u to the n minus 1 times u prime. Okay, very good. Now let's do some examples. D dx 3x plus 4 squared equals, and now we're applying the power rule to 3x plus 4 2 minus 1, and the chain rule, finding the derivative of the inner function times 3 equals 6 3x plus 4. And that is the solution. Let's do another. D dx 6x plus 3 to the 4th. Can we move the exponent to the front? 4 6x plus 3 to the 3rd, then times the derivative of the inner function times 6 equals 24 6x plus 3 to the 3rd power. Let's try another. D dx x squared plus 3 squared equals 2 x squared plus 3. So notice we haven't changed this to the first power, or the 2 minus 1. We haven't changed the inner function, and now we multiply by the derivative of the inner function. So times 2x equals 4x times x squared plus 3. And that is the solution. Okay, and one more. D dx x squared plus 3 to the 4th power equals, okay, power rule, 4 x squared plus 3 to the 3rd power, and now the chain rule times 2x, which is the derivative of the inner function, equals 8x x squared plus 3 squared. Very good. And now let's get into something slightly different. Let's do a quick review of trigonometric functions. So the derivative of sine x. So remember, we write derivative, we could write prime equals cosine x. And then the derivative of cosine x equals negative sine x. The derivative of tan x, or tangent x, equals secant squared x. The derivative of cotangent x equals negative cosecant squared x. Remember, you can write cosecant. Some people write it with the C-O-S-E-C and C-S-C. They mean the same thing. So I just wanted to give you a heads up on that. So the derivative of secant x equals secant x times tangent x. And the derivative of cosecant x equals cosecant x, the negative, times cotangent x. So sine x derivative, cosine x. Cosine x derivative, negative sine x. Tangent x derivative, secant squared x. Cotangent x derivative, negative cosecant x, negative cosecant squared x. Secant x derivative, secant x, tangent x. And then finally, the cosecant x derivative is negative cosecant x cotangent x. So let's jump in and do some problems to practice. So d dx of cosine x to the 5th power the derivative of cosine is negative sine. So we apply the chain rule and the power rule. So negative sine x to the 5th times the derivative of the inner function, which is 5x to the 4th power. That equals negative 5 x to the 4th sine x to the 5th. That's the answer. Let's try another. d dx of sine of 4x so the derivative of the outer function is cosine. For x, notice we leave the inner function alone. Then we multiply that times the derivative of the inner function, which is 4. And the final answer is 4 cosine 4x. Let's try one using tangent. So d dx tangent x squared. So what is the derivative of tangent? It is secant squared. So equals secant squared times the inner function untouched times the derivative of the inner function, which is 2x equals 2x secant squared x squared. Let's try another. So d dx secant of 3x to the 6th power equals. Now, we first are working with the outer function, which is the exponent. So 6 times secant 3x. Notice it's untouched. And then it's 6 minus 5, which is, 6 minus 1, which is 5, times secant 3x times tangent 3x times 3. So the final answer equals 18 tangent 3x secant 3x to the 6th power. Okay, another d dx. Let's try a cotangent problem. Cotangent x to the 4th equals negative cosecant squared x to the 4th times the derivative of x to the 4th, which is 4x to the 3rd, equals negative 4x squared times the trying to make the c legible, the cosecant squared x to the 4th. Good. And then our final problem, d dx. This will be a cosecant problem. Cosecant of 5x equals negative cosecant 5x times cotangent 5x times 5. Final answer equals negative 5 cosecant 5x times cotangent 5x. Okay, let's move on. Let's try some problems involving the natural logarithm and the e constant. So d dx, 3 times the natural logarithm of x plus cosine of x equals 3 times d dx of natural logarithm of x plus d dx cosine x equals 3 times 1 over x. Now notice, the derivative of the natural logarithm of x equals 1 over x plus negative sine of x equals 3 over x negative sine x. That's the final answer. So we'll circle that. Another d dx 11 natural logarithm x plus tangent of x equals 11 times 1 over x. And remember, 1 over x is the derivative of natural logarithm plus the derivative of tangent, which is secant squared x equals 11 over x plus secant squared x. I just want to jog your memory. Just remember dx of e to the x equals e to the x. So d dx of 27 ex to the x power plus secant x equals 27 e to the x power plus tangent of x times secant of x. And there we go. And let's try another one of those. So d dx of 13 e to the x power plus cosecant x. So equals 13. So notice we're using the constant multiple rule times e to the x plus negative cosecant x times cotangent x. Then the final answer equals 13 e to the x power minus cosecant x times cotangent x. Okay. So now let's take what we've learned and apply it to some problems. First, d dx of the square root of x third minus 5. So it's the same thing as d dx. And we're going to put it in a form where we can apply the power rule. X to the third minus 5 to the 1/2. Equals 1/2 x to the third minus 5. And then we subtract the exponent 1/2 by -1 or by 1. So we have -1/2 power times the derivative of the inner function. So that is 3x squared. equals 3x squared over 2 times x to the third minus 5 to the 1/2 power. And now we're going to put it in the original form using the square root symbol. So 3x squared over 2 times the square root of x third minus 5. That's the answer. And next, d dx 1 over x cubed plus 7 to the 4th power equals d dx x cubed plus 7 to the minus 4th equals -4. X cubed plus 7 to the -5th power times 3x squared equals -12x squared times x cubed plus 7 to the -5th power. And now in the final form equals 12x squared over x cubed plus 7 to the 5th power. And there we have our final answer. Let's try a couple of more trigonometric problems. So d dx of sine tangent x to the 4th. Okay, we start out with the outer function. So equals cosine, which is the derivative of sine. And then we leave the inner function alone in the beginning, x to the 4th times the derivative of the inner function, secant squared x to the 4th. And now the derivative of the most inner function, which is 4x to the 3rd, equals 4x cubed secant squared x to the fourth cosecant tangent x to the fourth, and that's our final answer. Then let's try another. D dx cosine the seventh sine secant x squared equals d dx cosine sine secant squared. I'm sorry, that's secant x squared to the seventh power. So equals 7 cosine sine secant x squared to the 7 minus 1 times negative sine sine secant x squared times cosine secant x squared times secant x squared tangent x squared times 2x. Now that is the actual answer, and we can simplify it to a degree. So you could combine the like terms like into 14x, but basically that's the answer. So this was really fun. I like all the parts, but especially the trigonometric problems. And I hope everyone has a great day, and see you in the next video.